You ever get that feeling you're talking to an AI that's, a brilliant mimic, but it doesn't actually get it? Well, today, we're going to look at a new architecture called the Semiotic Web. The whole argument is that we can push AI past just making good guesses to something like genuine comprehension. So let's dive in and see how it's supposed to work. Oh yeah, we've all been there, right? You ask an AI a question, and what you get back is this beautifully written, super confident answer that's just complete and utter nonsense. These hallucinations, they're not just some funny little quirk, they actually point to a really deep, fundamental problem with how today's AI is built.
Okay, so here's how we're going to break it down. First, we'll dig into what we're calling AI's credibility crisis. Then we're going to look at a three-part solution. First, a smart Lego approach to knowledge. Then, a system for giving that knowledge some real context. And a way to add the dimension of time. And finally, we'll see what it all adds up to. An AI that can actually comprehend.
Right, so the issue isn't just that the AI gets things wrong sometimes. The problem is way, way deeper. It really gets to the very core of what it even means to know something in the first place.
Now, epistemological is kind of a mouthful, I know, but the idea is actually pretty simple. Your current large language models, your LLMs, they just don't know the difference between a proven fact, an educated guess, or something they know absolutely nothing about. For them, it's all just one big statistical game of what's the most likely word to type next.
And this is a brilliant example of the problem. It's called the reversal curse. So if you train an AI on the sentence, Tom Cruise's mother is Mary Lee Pfeiffer, it learns that pattern. But then if you flip the question around and ask, who is Mary Lee Pfeiffer's son, it often just completely whiffs. It can't make that simple logical connection because it never understood the relationship. All it knows is the sequence of words.
So how in the world do you fix a problem like that? Well, the first step in the semiotic web is this idea called tokenization. The basic idea is, instead of treating knowledge like a long stream of text, you break it down into these secure, interconnected blocks. You can think of them like smart Lego bricks of information.
And each one of these little Lego blocks is called a tokum. Now, what's so cool about this slide is that analogy, digital DNA. A tokum isn't just a piece of data, it's a secure container that basically has its own ID card. It knows exactly what it is, where it came from, and who owns it. That gives it this unique, verifiable identity. And here's the crucial part. Here's how this solves that reversal curse. Let's imagine we've got a fictional author, Xander Blackwood, and his book, Quantum Chess. Instead of just a one-way sentence, we make a token for the author and a token for the book. Then we link them up in a special way that creates a two-way street. This special connection means you can go from the author to the book and, critically, from the book back to the author. Problem solved.
Okay, but just having verified blocks of knowledge isn't quite enough. You also need to know what kind of knowledge you're dealing with. And this is where the second big idea, semiosis, comes into play. It's basically a framework for creating meaning by organizing information into different contexts.
So the system has these three distinct layers. You've got the universal layer, which holds all the public global facts, like the dictionary definition of an algorithm. Then there's the organizational layer. This is your company's internal knowledge. Stuff like Project Phoenix is confidential. And finally, you have the personal layer, for your private notes and thoughts like, I think Project Phoenix is probably going to fail. And this structure is absolutely key. It means the system understands that your private opinion about Project Phoenix is not the same thing as the company's official policy, and neither of those is the same as a universal public fact. So for example, a researcher named Alice can link her new private hypothesis to a universal fact, and the system will never get confused and present her private idea as established truth. All right, let's move on to the third and final piece of this whole architecture. It's called semantic space-time, and it's all about making knowledge dynamic by adding the dimension of time. This might be my favorite analogy from the whole thing. It's like version control for reality. Think about it. Instead of a static photo of information that's instantly out of date, this system treats data as something that lives and evolves. It keeps a full history, just like a programmer would use version control software for their code.
So to make this real, just imagine a trust network. On day 1, Alice trusts her colleague Bob completely. But then, on day 30, something happens, an incident, and her trust level plummets. Then, by day 60, he does something to redeem himself, and her trust is restored. A normal database would just overwrite the old value. All you'd see is that her trust is high now, but you'd have no clue why.
But semantic spacetime?
It doesn't overwrite a thing. It saves the entire timeline. And this lets the AI reason about causality. It doesn't just know Alice's trust is high now, it knows her trust was low because of the incident, and it was restored after he redeemed himself. It actually understands the story.
So when you put all three of these innovations together, the tokums, the semioses, and the spacetime, you end up with something that feels fundamentally new. You get a real shift from an AI that just generates text to one that actually comprehends information.
So let's just recap really quick. You start with tokums, these verified trackable blocks of data. You add semiosis, which gives you clear context for what that data means and where it belongs, and then you layer on spacetime, which gives the data a complete history and the ability to evolve over time.
And all of this leads to an AI that can do something modern models are, well, terrible at. It all comes down to a simple question. What are the 3 magic words that a modern LLM just can't seem to bring itself to say?
I don't know. It's that simple. Because current AI is designed to always give an answer, it just fills in the gaps with plausible-sounding garbage. But in the semiotic web, if there isn't a link between 2 tokums in the knowledge graph, the system knows there's a gap. It doesn't have to guess. It can just, honestly, say, I don't know.
And that right there is the ultimate payoff. We move from artificial intelligence, which at its core is about predicting the next most probable word, to what you could call artificial comprehension. A system that truly understands the relationships between concepts, the context they live in, and their entire history over time.
So I'll just leave you with this question to chew on. If we can actually build an AI that gets context, that respects the line between a public fact and a private thought, and that has the humility to admit when it doesn't know something, how does that fundamentally change our entire relationship with technology itself?